Welcome everyone to another lesson from Mr. Swank for Chemistry 1. We are starting our new chapter today, which this is going back to Chapter 3, Scientific Measurements. So we're starting this today. And yes, I know that we were up to like Chapter 11 before, but we're going back doing a little bit of the math stuff because it's where we were going to end the year. But that is where we are heading off to today. Now, it wouldn't be one of my lessons if I didn't start it with the joke of the day. So let's do this. So joke of the day. You know, I've been so bored throughout this whole thing that I memorized 6 pages of a dictionary. I learned next to nothing. Next to nothing from next to nothing. Yeah, it's like 6 pages in the dictionary. You missed this, right? Okay, let's move on. So let's start by taking a look at our objective for this lesson. The objective for this lesson is to identify a measurement as qualitative or quantitative and discuss the metric system. So this might sound like a review to you. You've probably learned about the metric system. Actually, I'm really certain you've learned about the metric system in the past. But this is something we've got to go over and talk about because we'll get to it. But let's start by talking about qualitative and quantitative. So there's different styles of measurements when it comes to science. There are qualitative and quantitative. So let's take a look at those. Qualitative describes a quality. So what does that mean? What it is qualitative measurements are descriptive. That means that they're talking about features of something or just basically any description of it, but it's not numerical. It's not. We're not talking about numbers. We're not talking about how long something is, how massive it is, how much volume it takes up. We're talking about descriptors for it. What do I mean? Well, here's an example. Mr. Swank's jokes are terrible. That's a qualitative measurement, because you're describing the joke. It's descriptive. There's no number to it. It's simply just telling somebody something about those jokes. Quantitative describes a quantity. It's talking about a number. This is definite, numerical. Now, that word definite means there's no subjectivity to this, meaning there's no chance that this is going to be misconstrued, because with qualitative, for example, maybe you saw that Mr. Swank's jokes are terrible and thought his jokes aren't that terrible. Unfortunately, when you describe something, it can be subjective. Think about it. You ever get into an argument with somebody over what color something is? But quantitative measurements are definite. They're numerical. You can't argue with somebody over how long something is or how massive it is or how much volume there is, because you can measure it and prove definitively how much it is. So the example here is Mr. Swank's jokes made me laugh 0 times. You can measure that. If you didn't laugh, that's 0. That's a number, and that's a quantitative measurement. So let's take a look at a more practical, actual scientific example. So what I have here is a flask of liquid. Can we all see this? This beautiful liquid. So this liquid we can describe with various measurements. For example, we go back to qualitative. Remember, qualitative is descriptive. So in this case, we can describe it as it's a liquid. It's kind of pinkish and cloudy. But then when it comes to quantitative, that's a numerical one. So what can we say numerically about this? Well, if we look at it, I can see that it comes up to about the 400 line, meaning there's a little less than 400 milliliters in here. That's a number. That's quantitative. Remember, qualitative, quality, quantitative, quantity. That's the difference there. Now, with qualitative measurements, there isn't a whole lot to say. I mean, you do it however you want to. For example, that's nice and sweet. Don't do this at home. But somebody might not agree with me, but there's no rules dictating that. But when it comes to quantitative measurement, there is rules dictating how we do that. And in this particular case, we have to look at the system of measurements we use to get quantitative measurements. And that brings us to, the systems we use. So in the US, we use the US standard system of measurements. It's different from the rest of the world. I think there's 2 other small places that use it, but no other place uses it. Do you know why? Well, if you think about it, we use inches, feet, pounds, gallons, etc. to do all our measuring, but it's stupid. Our system of measurement is broken. What do I mean? How many inches in a foot? 12. How many feet in a yard? 3. How many yards are in a mile? Can any of you tell me that? It's 1,760. You might know how many feet are in a mile, 5,280. But still, that's stupid. Where are these numbers coming from? How many ounces in a pound? 16. How many pounds in a ton? 2,000. None of this makes sense. Water freezes at 32 degrees Fahrenheit and boils at 212 Fahrenheit. Why these numbers? Which is why the majority of the world and all modern scientists use the metric system. This system is based around the idea that every unit can be converted into another by base 10. Example, there are 10 millimeters in a centimeter, 10 centimeters in a decimeter, 10 decimeters in a meter. The same thing works for other things, such as grams, which they measure mass in. 10 milligrams in a centigram, 10 centigrams in a decigram, 10 decigrams in a gram. And if you notice there was a pattern there with centi and deci and all that, we'll talk about that. So they're also referred to as SI units, International System of Units. Well, let's talk about the units that we actually use in metrics. Some of them you're probably familiar with, other ones, maybe not so much, but we will get into them. So first, let's talk about length. Length, of course, the distance between any 2 points, whether it's this way, this way, this way, you're familiar with it. You use a ruler or a yardstick typically to measure it. The base unit of measurement in the metric system is the meter, which is about a yard, a little bit more, but that's the base unit. When it comes to volume, the amount of space an object occupies, we use liters as the base unit, L, or a lot of times you might see it in centimeters cubed. We'll talk about that later. Of course, volume, typically liquids and stuff like that, but you can measure the amount of space any object occupies. We measured volume with this earlier when we talked about quantitative. Mass, the base unit is grams, and you've probably seen that before because you've probably used a balance or something like that. Temperature in science is measured in Kelvin. The reason for that is the base 0 is the lowest possible temperature, absolute 0. Amount is one you might not have heard of before. Amount is measured in moles. We are going to talk about moles extensively in the next chapter, but what do I mean by amount and mole? That idea is similar to if you get 12 of something, that's a dozen. A dozen is a unit for an amount. It's 12. A pair is another unit for amount. A pair is 2. A gross, being another one, a gross is 144 of something. We have words to describe amounts. In science, when we talk about an amount of something, particularly in chemistry, we refer to them in groups called a mole. And again, we'll get to that. Time is measured in seconds because most of the time when something's happening that you're measuring time for, you're measuring it in seconds. But of course, we can use minutes, hours, whatnot. That's not very different from what you're used to. Pressure is measured in pascals. We're not going to worry about that much this year. If you move on to Chem 2 or AP Chem, you'll probably see it there and talk about it a bit more then. And then lastly, energy is measured in joules. Again, that's another Chem 2 AP Chem thing. Don't really need to worry about that for this year. Just know that energy's base unit in the metric system is joules. So that's the basics of the metric system and the basics for quantitative measurements. Remember, there's qualitative, quality, where you're describing something. It's important because keep in mind, if you told somebody you made a liquid in science, but you didn't tell them it was pink, you're leaving out an entire important part. But when it comes to quantitative, there's a bunch of rules that we need to talk about, and we're going to keep moving forward with that. So remember your metric units and give that assignment a try that's posted for today. It's all about the metric units and qualitative and quantitative. But hey, thanks for watching, everyone. Tune in tomorrow. We're going to review this stuff, and then we're going to move on from there. But hey, I'll catch you later.